Hey, what's up guys? In this video we'll be going over the basics of moments and torque. The purpose of this video is just basically to give you an understanding of what it is, the concept, the basic concept, and the terminologies which are used when dealing with moments. So let's say we have a beam here which is 10 meters long and we have a force which is 10 newtons. Now a moment is a force that is applied at a perpendicular distance from the pivot point. As we can see here, we have a 10 Newton force that is applied perpendicularly from the pivot. Now this distance here between the pivot and the force is known as the moment arm, and this is important to remember as many students will often say that the moment arm is the entire distance of the beam, which is incorrect. It's actually the distance, only the distance between the pivot point and the force. So I put a force here just to demonstrate. We have a force here, let's say that it's 5 newtons. So the moment arm for this force will be the distance from the pivot point up until this force here, not the entire beam. So now what are the units for a moment? Now moment is the product of the force here, whether it's 10 newtons or 5 newtons, times the moment arm, the distance of the moment arm. So a moment is the force times the distance, as we have here. Moment is equal to the force times the distance. And the units for those are, the force is, we know, well, we should know, is newtons, and the moment arm is measured in meters. So the SI units for moments is Newton meters. Now by convention we say that clockwise moments are always negative and anti-clockwise moments are always positive. I added two forces over here, another 10 Newton force and a 5 Newton force. So these two forces on the right are going in the clockwise direction, therefore they are negative. So if I were to calculate the moment here, the force 10 newtons times the moment arm, the product of that will be negative. If I were to calculate the moments over here, they're going anti-clockwise, so it would be a positive value. Now let's do some quick calculations here just for demonstration purposes. We'll start on the right hand side. We'll say this, the moment here. We'll say the 10 Newton force times, we'll assign a value here. We'll say 5 meters times 5. That will equal to 50 Newton meters. Now for this 5 Newton force here, this will be 5. We'll assign a value, let's say 3. This will be 15 Newton meters. And this is going clockwise, so these will be negative. Now we'll do this side. The moments over here, 10 times the same 5. This will give you a positive 50. And then the 5 times the same 3 meters. This will give you a positive 15 Newton meters. So this is going anti-clockwise, so these values will be positive. Now this brings us to the principle of moments, which states that for a system to be in equilibrium, the net moment must be 0. In other words, the sum of the clockwise moments must equal the sum of the anti-clockwise moment, or the sum of all the moments must equal 0. To demonstrate this, we already have the values here. the moments for the right hand side of the beam will equal to negative 65. You might can't see it here. Let me just shift it over a little. Negative 65 Newton meters. Sorry about this. And the moments, the sum of the moments on the left hand side will equal positive 65 Newton meters. And if we were to follow the principle of moments, we can say that the sum of the clockwise moment must equal the sum of the anti-clockwise moment. So if we were to add these two together, we'll get 0. So in theory, this system should be in equilibrium. So that pretty much covers the basics of moment and torque. You may have noticed something strange here. The units for work is also force times distance, and that is known as the joule. However, there's a key difference between the two. Let me demonstrate with this ruler here. So when you're doing work, you're actually applying a force which moves the entire object through a distance. Force times the distance it moved. When you're talking about moments, let's say my finger here is the pivot, and we apply a force perpendicular to that pivot, it causes the object to rotate about an axis. So work actually makes an object move through an entire distance, while moments make an object rotate about an axis or a pivot. So in our next video, we'll go more in depth with moments, and we'll solve some problems as well. So we're actually going to apply what we discussed here and use that information to solve problems. So thank you guys for watching, and see you in the next video.